Alright, so we're going to be doing basic trig identities. So first we're going to review a little bit on factoring. So these are perfect square trinomials, and what that means is that the x squared and the negative 16 or the minus 16 are both perfect squares, meaning you can take the square root of each one and get a whole number. So x times x gives me x squared for 16. 4 times 4 gives me 16. Sorry, x times x gives me x squared. 4 times 4 gives me 16. One is going to be plus, the other one is going to be minus. Okay, and that's what your perfect square trinomial is. So here we have cosine squared of x. So cosine times cosine is going to give me cosine squared. And then 8 times 8 gives me 64. One is plus, one is minus. Okay, then we have factor 1 minus x squared. So because the 1 is first, okay, another perfect square, 1 times 1 is 1. And x times x is x squared. One is going to be plus and the other one is going to be minus. Okay. So then when we do this with the sign, we have 1 times 1 is 1. And to get sine squared of x, we do sine of x times sine of x. And one will be plus and one will be minus. And that's it. All right. So a trig identity is an equality that involves trig functions and that is true for all values for which the variables are defined. There are a number of identities that connect the trig function. So our first one is the reciprocal identities. So if sine of theta is equal to y, which we established before, then that means that cosecant is 1 over y. Okay. When cosine, we said cosine is equal to x, so secant is 1 over x. And last, tangent is the y value divided by the x value, so cotangent would be x over y. But as we know from the trig ratios, if we know that sine of theta is equal to y, then instead of y, we're going to plug in a sine of theta. So cosecant is equal to 1 over sine of theta. For cosine of x, since cosine of theta is equal to x, then here instead of x, we're going to plug in a cosine. So secant of x is equal to 1 over cosine of theta. Okay. So those are the reciprocal identities. So the opposite of sine is cosecant, so it would be 1 over cosecant. The opposite of cosecant is sine, so it would be 1 over sine. Okay. For cosine, it'll be 1 over secant, and the opposite of secant is cosine, so it's 1 over cosine. Okay. We can also do this with our tangent and cotangent. So the opposite of tangent is cotangent, so it'll be 1 over cotangent, and cotangent is equal to 1 over tangent. These are called our reciprocal identities. Okay. Now, our ratio identity. So if tangent of theta is equal to y over x, we know that y is equal to sine. And we know that x is equal to cosine. So we had established this before as well, that tangent of theta is our sine divided by our cosine. For cotangent, it's going to be the opposite. So it's going to be the cosine divided by the sine. Alright, so then these are called our ratio identities. Okay. Next is the reciprocal. So the reciprocal and the ratio identities can be squared to form new identities. So if cosecant squared, then the sine must also be squared. Okay. So if we're using secant and secant squared, then that means that the cosine is also squared. So it'd be cosine squared of theta. Or here, if cotangent squared of theta, it is going to be sine over cosine. So no, cosine over sine. So cosine squared of theta over sine squared of theta. Okay, and then the same goes for your reciprocal, or what was it called? Your ratio identity. So if tangent is squared, then the sine and the cosine are both squared as well. So then for this one's going to be cosine squared of theta over sine squared of theta. I actually think I did this one wrong. This one should be 1 over tangent. Sorry. 1 over tangent. Okay. So now, Pythagorean identity. So these come from our Pythagorean theorem. So if I look at my triangle here off to the side, we have a squared plus b squared equals c squared. Okay, in this case, my a is x, my b is y, and then my hypotenuse is 1 squared. Okay, but because we know sine of theta is equal to y, this is sine of theta, it'll be squared, plus, and we know cosine of theta is equal to x, so this will be cosine squared of theta, and 1 squared gives us 1. So this is where they get this identity from. Okay. So we have a few other Pythagorean identities. We have sine squared plus cosine squared equals 1. We also have 1 plus tangent squared equals secant squared, and 1 plus cotangent squared of theta equals cosecant squared of theta. Okay. Now from these three identities, you can get several new identities. So for example, here we have sine squared of theta plus cosine squared of theta, which is the first one here. The 1 plus tangent squared of theta. So we can rewrite these to create different identities. So if we look here, say we want to solve for sine, or we want to know what sine is. To get the sine by itself, we move the cosine to the other side by subtracting it, which is what we have here. Okay. So we know that sine squared is equal to 1 minus cosine squared. But if we were to factor that, we know 1 times 1 gives us 1. Do 1 plus, 1 minus of cosine of theta. And that's how we get negative cosine theta squared. Okay. So not only is sine equal to 1 minus cosine, but it's also equal to 1 plus cosine of theta and 1 minus cosine of theta. Oh, I shouldn't have this squared here. Sorry. Okay, now what if we're trying to get the cosine of theta by itself? So then instead of moving over the cosine of theta to the other side, we would move the sine of theta to this other side by subtracting, and we get 1 minus sine squared of theta. If we rewrite that or we factor that, that'll be 1, and then we have plus sine of theta, 1 minus sine of theta. Okay. We're going to do the same thing for our other identities. So our next one's 1 plus tangent squared of theta equals secant squared of theta. Okay. So if we're just trying to get the tangent by itself, we have to move the 1 to the other side by subtracting. So that's how they got secant squared of theta minus 1. We're going to go ahead and factor that. So secant of theta minus 1, secant of theta plus 1. 1 is plus and 1 is minus. All right, this next one, what they did here is instead of having 1 plus tangent of theta equals secant squared, they got the 1 by itself, so they moved the tangent to the other side by subtracting, and they got this. So when we factor this, we have secant of theta plus tangent of theta times secant of theta minus tangent of theta. Okay. And then the last one that we're going to manipulate, so we have 1 plus cotangent squared of theta equals cosecant squared of theta. So here, we are going to move over this one to the other side by subtracting, which is what they did here. And so cotangent squared of theta is equal to cosecant squared of, oh wait, not squared. So cosecant of theta times cosecant of theta gives me cosecant squared of theta. And then 1 times 1 gives me 1. 1 is going to be plus, 1 is going to be minus. And so the next one, they move the cotangent to the other side by subtracting, and we get cosecant squared of theta minus cotangent squared of theta equals 1. So cosecant of theta, cosecant of theta. And then 1 is plus, 1 is minus, and then the next one would be cotangent of theta. So these are the formulas that we're going to use. We have 3 different formulas that we're using. We have our Pythagorean identities, we have our ratio identities, and our reciprocal identities. Okay, this is just an explanation where they come from. If you didn't understand any of the explanations, that's fine, as long as you use these formulas. So we're going to be using those formulas. So starting here, we have sine of theta times cotangent of theta. And we need to simplify it or make it as, how would I put it? We need to simplify it to make it as short as possible to at least one trig function. So I know that cotangent of theta, if I look here, these are squared, so this is not what I'm looking for. My ratio identities, I know cotangent here is equal to cosine over sine. So that's what I'm going to do. I'm going to substitute that for cosine over sine. So cosine of theta over sine of theta. Okay. And then this sine of theta is going to stay there. I'm not going to change it. And so I have a sine of theta on top and a sine of theta on bottom. They cancel each other out, and all we're left with is cosine of theta. And so that would be simplified. Okay. All right, so next here we have cosecant of theta. Okay. I am going to use my reciprocal identity. So I know that the opposite of cosecant is sine. So I'm going to write it as 1 over sine of theta. This top part, I have sine squared of theta. I'm going to go ahead and just split it into 2. I'm going to write it as sine of theta times sine of theta. And then on the denominator, we have cosine of theta. That one I'm not going to mess with. I'm going to leave it the way it is. Okay, so when we're simplifying now, I see that I have a sine on top and sine on bottom. So I'm going to cancel it out. So I'm still left over with sine of theta times 1 on top. So sine of theta times 1 is just sine of theta. And on the bottom, I have cosine of theta. Okay, and then this one is going to be sine over cosine. If I look up here, this is my tangent is sine over cosine. This is my ratio identity. Okay, so I know sine over cosine is equal to tangent. That would be my answer. Okay, the next one. So here I have cosecant squared of x, and then in the parentheses I have 1 minus cosine squared of x. So I know this is one of my Pythagorean identities, so I'm going to go ahead and look to see what is 1 minus cosine equal to. It's actually right here. 1 minus cosine squared is equal to sine squared of theta. So that's what I'm going to write here. Sine squared of theta. Okay, so I made that substitution. And then I have this cosecant squared of x. So I know the opposite of cosecant is going to be sine. So I'm going to rewrite it as 1 over sine. And because it's squared, I have to square the x. Oh, I changed it from x to theta. It doesn't matter. It means the same thing. Okay, so now I have a sine squared on top, a sine squared on bottom. They both cancel each other out, and we're just left with that one that's on top. All right, the next one we have sine of x plus tangent of x over sine of x times tangent of x. So we're going to review real quick adding and subtracting fractions. So if I do 1/2 plus 3/2, since we have a common denominator, we can put it on top of the same common denominator, and then we add the numbers on the top, 1 plus 3. So I'm going to work backwards. I have these two adding. I'm going to split it into 2 different ones. So I have sine of x plus tangent of x. Okay, and my common denominator is the sine of x, tangent of x. Okay, and since I'm simplifying, since I have a sine on top and a sine on bottom, they cancel, and I'm left over with 1 on top, and on the bottom I have tangent of x plus, here the tangents cancel, and I'm left with 1 over sine of x. Okay, our last step to simplify is the opposite of tangent, because this is 1 over tangent, is cotangent. Plus, the opposite of sine is going to be cosecant. Cosecant of x. And then that's it. Okay, the next one, here we have sine of x times cosecant of x minus sine of x. So first, I'm going to go ahead and distribute the sign to each one first. So I have sine of x, cosecant of x, minus sine squared of x. Okay. Now, I know cosecant is the opposite of sine. So I'm going to go ahead and rewrite it as 1 over sine of x. Okay. Everything else I'm going to keep the same. So then these signs end up canceling out, and we get 1 minus sine squared of x. Okay. Well, this one happens to be my Pythagorean identity. So if I look at my Pythagorean identities up here, sine squared of x is equal to 1 minus cosine squared. So cosine squared is equal to 1 minus sine squared. So this is equal to cosine squared of x. And the last example, so on the top I have cotangent squared of theta, and then on the bottom I have 1 plus cosecant of theta. So this reminds me of the identities, okay? And then I have plus sine of theta, and right away I can see that cosecant is the opposite of sine. So I'm going to be able to cancel something out by changing it to 1 over sine of theta times, this one stays the same, we have this plus sign. On the bottom, I'm going to keep this the same, 1 plus cosecant of theta. And then the top part, the cotangent squared of theta, I am going to switch that out. Let's go ahead and look at my, here they are. So here they tell us cotangent squared of theta is cosecant theta plus 1 times cosecant of theta minus 1. So I'm going to switch that out. Cosecant of theta plus 1 times cosecant of theta minus 1. And the reason I'm using that one is because I have this on the bottom, so that tells me that this is going to cancel out. Okay, so then I'm left with cosecant of theta minus 1. That one didn't cancel out. Then we have plus. These signs of thetas canceled each other out, and we're just left with 1. Okay, so here, negative 1 plus 1, that cancels, and we're just left with cosecant of theta. That's it. So if you guys have any questions, you guys can stay on here. If not, I am done for today. Thank you guys. Bye.